Is the comparison between refrigerator related of power inverter. In an on and off cycle of a regulator refrigerator, inside temperature varies throughout, but in case of inverter technology, temperature is more stable. The amount of noise made by the refrigerator is much less in refrigerator with inverter technology as compared to the regular one. Energy of electricity consumed of much less when the temperature stabilizes.
Regular motor need 3 until 4 times more current at start. Regular motor need 3 until 4 times more current at startup. So the inverter generator size need to run any AC or refrigerator increase significantly. Regular motor have much lower power factor. In commercial and industrial connections, there is penalty for low power factor and rebate for higher power factor. If you are planning to use solar PV for air conditioner, then it is the best to use inverter technology, air conditioner or refrigerator, as it not only reduces the size of PV panel because it consumes less electricity, it also reduces the size of inverter to be put along with the PV panel.
Inverter is an electrical device that converts DC battery power into 120 volt AC household power to run appliances such as a refrigerator. Inverters are available in different power capacities, and some are powerful enough to operate refrigerator, but before you run out to buy an inverter, you need to figure out how big an inverter you need and how much battery capacity it will require.
Power draw. Before shopping for an inverter, you need to know the power draw of your refrigerator in watts. This information is found on the manufacturer nameplate expresses as M or watt. If the plate gives the watt, you are home free. If M are given, convert M to watt by multiplying the M times the voltage. For instance, if your typical 16 CU featuring fridge draw 6 amp, you multiply by 6 by 120 volt to get 600 watt. That is your running wattage. A fridge motor also needs a jolt of about 3 times its running watt to start up, but this surge is needed for only a fraction of a second. To run this refrigerator, you will need an inverter that can handle 600 watt for a long period and surge of 1100 watt for a split second.
Inverter ratings. The manufacturer label on most inverters give two capacity values. The continuous wattage is the AC power output the Inverter can supply 24/7 for as long as the DC input lasts. The peak surge wattage is the AC power output the inverter can supply for a split second. A typical inverter offered at discount stores or home centers provide 1,500 watts continuous AC power and 3,000 watts of surge power. This unit should run a typical 16 cu feet refrigerator with no problems.
Battery capacity. You also need to know how much DC battery capacity you have to have on hand to run your refrigerator. To determine your battery requirement, first convert your refrigerator AC running watt to DC ampere. The starting wattage does last long enough to cause to find DC ampere, divide AC running watt by 12 and multiply the result by 1.1. A fridge needing 600 AC running watt will draw 55 DC ampere.
Battery ratings. Lead acid rechargeable batteries are rated in ampere hours. A typical battery rated at 105 ampere hours can deliver 105 DC amps for 1 hour before it runs out of power. In general, you risk damage if a rechargeable lead acid battery is drained below 50% of capacity. So, you safely can draw 150 amps for only 30 minutes. A fridge drawing only 55 DC amps can be run for about 60 minutes of continuous duty of a 105 ampere hour battery. Refrigerators run intermittently, not continuously, so you need to determine how many minutes out of each hour your refrigerator actually runs. If your refrigerator draws 55 DC amps for 20 minutes out of each hour, you will need to recharge your battery after 3 hours of refrigerator operation. A second battery will keep your fridge running while you recharge the first battery.
Okay, ini ialah perbezaan peti ais yang dahulu dan peti ais yang sekarang. Terima kasih.